it back into my notebook because I didn't for some reason.
You
Ripped it out. Yeah, I don't know what I was thinking. What?
We listen to others. So we listen to others.
I know. Ever.
Yeah.
Okay, here's another way you can
You
introduce
don't, you
additions.
can't do it like it.
If you want to use a text or a book, so maybe the students, you've read this to the students before, how many snails, a counting book, and maybe you've used it when you counted actually, when you were learning how to count, okay? So we can also adapt this for addition. Okay, so I went walking, and I wondered how many clouds were there? You know, the students saying, okay, we've done this before, we count, let's count the clouds, 1, 2, 3, 4, 5, 6, 7, 8, okay? How many clouds were there? 8. How many clouds were big and fluffy? They might say 1, 2, 3. Okay, how many clouds were big and fluffy and gray? 1, 2, 3. Oh, 1, 2. That's a trick question. Okay, now what I can do with this is I can say, well, how many are gray? They can say 4. Okay, and how many are white? And they'd say 4. How many altogether? 8. All right. So if they don't know addition, I could use this and do exactly the same thing. I could use this to build on what we just learned. So let's say this is the next day after what we just learned. I can say, how would I write that in math? You know, we had 4 gray ones and 4 white ones, and we brought them together, we counted them all up. See how I'm starting to expand now the meaning of this bringing together? Okay? Because right now it's very limited. Okay? So if we bring them on, can you show me with the blocks what that would be? You have to do something like that. Okay? But they're showing you parts here. Okay, so I went walking to the meadow and I wondered how many flowers were there. Okay, so we counted them up, 1, 2, 3, 4, whatever it is. How many flowers were yellow? How many flowers were yellow with black centers? And then I can go ahead and change this however I want. I could say how many are pink? How many are white? How many are pink and white? Okay. So 4 are pink, so I can write that on the board. White is 2. If I want to count them all together, if I want to add them, 4 plus 2, that's 6 total pink and white flowers. Okay? This book, by the way, we'll also use for when we introduce fractions.
So when we do each of our lessons, are we always trying to pair it with a book like we do our ELA lessons, or sometimes you pair it with a book?
You don't have, at least not in my class, you don't have to. But I mean, it is always a good idea if you can find a book.
Like during circle time or something like that? That's
Yeah.
great.
And the more connections you can make, just like we're doing with the clock, you know, we're in the middle of doing some other kind of lesson, some other activity, and then we just say, hey, look at that, you know what I mean? So now it's like authentic. So if you might have been reading this book to introduce some terms, I don't know, you know, some vocabulary, or you want to do something with about clouds, you know, about weather or something. All right, so you read this book, and then right there on the spot, you might say, oh, you know what? How many black clouds? How many dark clouds? How many? And so on. Okay? All right, take a look at this. First grade class. kind of challenges that we face in the classroom. The good thing is they're using manipulatives. Now, a lot of times they won't be using manipulatives. And really what I want to show you with this, about this is the idea of teaching key words and how limiting that is. Because if you see here, the key words, the one child, is it Hong? Yeah, Hong says, she says, the story says more. So she's looking at the key word more, so there's 13. All right, so they aren't comprehending the problem. At least that's what key words do. When you teach key words, you're really teaching students, look for the words, don't understand the situation. And that's exactly what we don't want people to do. Okay? So if I'm teaching somebody key words and they see this more, they're going to say, well, 9 and 4 is 13. It must be 13, just what Hong is saying. Does that make sense? And she's getting the idea from me. I taught her that, if I taught her the key words. Okay? It might work for the problems I give her on a certain day. Okay? It might get her through those problems and I'm happy. Oh, good, they got through those problems, she's doing them right. But now, later on, these terms are used a lot of different ways and it's hurting them. So what you really want to do is, and it's hard to get, especially very young students, to discuss with each other or even listen to each other, okay? But like they're kind of in a little group and talking. You're lucky if you get that in the first grade class. That's pretty good. But what you want to do is you want to say, well, what made you do this? Okay, why did you decide to add them? Why did you decide to take them away? And then let them kind of explain it. And if there's any words in there that made them do something, that's the time to highlight it. But it's not to say just look at the word more. Okay? It's saying, oh, you were looking at that as 9, 4, so I was, they're saying, so that means I have to get some more to get the same as whatever they want to say. Does that sort of make sense? Keywords of really, because you can even go to the extreme and you can say, Terry has 15 of these things, Terry gets 25 more of these, what's your name? And the students will say, oh, it says get more, 15 and 25, 40. So that's not even the question. The question is what's your, because they get so focused on that. And in this case, you can see it's a subtraction problem, but more we associate the word more with addition. So we're actually training them not to comprehend the problem, and that's not good. Remember, contextualize, we have the thing in context. In context is the way that you figure it out. Okay? Any questions about that? Okay, there's you see at the bottom it says keywords are not to be shown as a strategy. Kind of, I just give you kind of the same type of problem, or a similar type of problem where the key word's going to mess you up. George has 9 blocks, Shelley has 5 blocks. How many more blocks does George have than Shelley? Actually, it's the same problem, isn't it? Pretty close. Okay, so there are 4 types of addition situations. The last 2 to me are so similar, I would never ask you to tell me the difference between the last 2. Now, this is on your Blackboard site. Types of addition problems. So if you go to course documents, you have this here. The first situation is the one that we use to introduce addition to the students. That's a change happened. Okay, I was playing the 2 turtles. I wanted to get more, something changed. I went to get some more. Okay, so that's called change add to, and that's usually the way we introduce addition situations. Okay, but as you saw, remember when I was talking about when I introduced the plus sign, I said, when you bring them together or whatever I said for that there, it's very limiting. Okay, they got the idea right now, but we're going to expand it, and that's what these are doing here. They're saying, okay, but that's not the only type of situation. Change, add to, or use addition. We use addition here where there's been no change, and that's kind of what I was doing with the clouds. Jimmy has 4 red blocks and 2 yellow blocks. How many blocks does he have altogether? That's where you have 2 parts and they make up a whole. Nothing changes. And so remember that picture of the clouds were already there. There was some gray, there was some white. So 2 parts, that make up a whole. The last two are compare and equalize, and you see how they're very similar. Tanya has 2 frogs, Jan has 6 frogs. How many more frogs does Jan have? Now, we're used to thinking about that as subtraction. For these students right now, at the level we're at, that we're talking, they don't know subtraction. So you're going to turn it into an addition problem. It's a hard one for them to turn into an addition problem, but they can't. They'll say 2 plus what equals 6. That's a hard problem for them. We usually don't spend a ton of time on that because we get the subtraction pretty quick. Tim has 5 triangles, Kathy has 3 triangles. How many more triangles does Kathy get to have as many as Tim? Okay, so that would be 3 plus 2 equals 5. And remember, we're talking about kindergarten, 1st grade. Remember the video? How many more do you have to get? Remember the students didn't understand that terminology? They can do the problem, we just can't get the question that they can understand it. So we think a lot of times, oh, we don't know how to add or something. It's like, no, we just aren't communicating what it is. That's also a big thing with special needs students, learning disabilities. They can do it, it's just that we can't get the information in there with the techniques we typically use in the classroom. Okay? Okay, those are 4 types of addition situations. Let's see here real quick on Blackboard. Course documents. Let's see it. Types of addition, subtraction, word problems. Let's go to that. This is another a very similar set, so there's things we're looking at. Okay, so that's on there. There's also this, what I'm going to show you right now, basic addition facts. So you do have this here, so you don't have to scribble all this on what I'm going to show you right now down. I'm going to show you on the smartboard. Either one is going to know that. I can't get it all up here anyway. But now we're in 1st grade, and now's the time for them to learn their basic facts. So, I'm de-emphasizing memorization, but I'm not cutting it out. Memorization is still an important part of math. We just aren't over-relying. Okay? And this is the part where we're going to let them to memorize the basic addition facts, from 0 plus 0 to 10 plus 10, even 11 and 12. Some schools do 11 plus 11 and 12 plus 12, and go as high as that. Typically, it's up to 10. Now, what we're going to do is we aren't going to use time tests or just strict memorization. We're going to try and get them to see relationships to build these facts, something that makes sense to them. All right? Horizontal number sentence, that's what this is up here. Commutative property, that cuts the facts in half. So if they are learning these, well, I want to take those 100 facts and cut them in half. Now they have to learn 50 if they understand the commutative property. Again, I'm going to show you how to use that here in a second. We're going to use word problems or class situations for them to figure out what these answers are. I'm not just going to say 3 plus 5 is 8. Everybody say it 5 times. I'm not going to do that. We're going to use manipulatives, problem solving. They're going to explore and find patterns. Okay, they're going to start seeing some of these patterns, the patterns that we think are really easy. Sometimes they don't see them right away. Let's see. They're probably the most important basic facts of all because subtraction and multiplication rely on them. So they don't have the addition facts. I'm going to show you something for subtraction and multiplication. They're going to fall apart in those two because they rely on addition. So addition is really the one that's the foundation. And it's different than the traditional approach, more sense making. We're building on students' understanding. So you begin with the commutative property. And so we know the students can write their one addition. An addition problem is we were using the blocks here. Okay. So I could put this up on the screen. I could have the students have it in front of them. I can say, okay, you know, we've been doing addition now for a few days. What's that addition problem? I say 3 plus 5 equals 8. Right now. Okay. Now, if the students have the blocks there, that's okay. If not, in this case, you know, if they're watching, it wouldn't be so bad. If I said, okay, I'll turn it around like this. Have I changed the total number of blocks? No. Okay, but what's the addition sentence now? 5 plus 3 equals 8. Okay? So I just got my first piece of data on the board. I'm going to do a few more problems just like that. Turn it around, say, have I changed the total number of blocks? No, but the addition changes. The addition problem changes. Okay, now I'm going to say, what do you notice about these two problems here? You know, they're going to give you a lot of different things, but you know, they have the same things over here with their switch. That's kind of what you're getting at, but the answer is the same. What about this one? Oh yeah, the numbers are the same, but they switch, and the answer is the same. Okay, so do you think that's always going to happen? So there's the pattern. And they're saying, you know, do you think it's always going to happen? Give me let me try a problem here. So you're saying, if I have 3 plus 7, what's 3 plus 7? You know, 10, okay. You're saying that if I switch those, I should have 10 still? Let's try it out, okay? And they try it, and it's working. But they're the ones who come up with the conjecture, right? They're the ones who came up with the rule. Oh, so we can always just turn those things around. Is that right? Is that what you're saying? Yeah, that's what we're saying. Just move those around, the answer is the same. Let's try another one. Okay, so that's me taking them in through the explore, find patterns, where they make the conjecture. They come up with the rule. They come up with the commutative property for addition. Okay? And that's how I get them to tell me. If they tell me the rule, they must know it. If I tell them, you can just, see, because in traditional, we would just say, well, you can just flip those around and you get the same answer. And now students have said, what? You just changed the, how did you get the same answer? Okay, that's a traditional way when we're telling them. So already here in late kindergarten or first grade, if I'm introducing this, I'm already in a traditional class encouraging or making math very mystical for students. They don't understand. It's not something that they can figure out. It makes no sense. And that's probably where a lot of us began thinking math makes no sense, you know, these kinds of things. Whereas if I show it to them this way, they're telling me it's got to make sense if they're telling me. They get it. That's what you always want the students to get it. Okay? So that's the commutative property. You aren't worrying about the word. You're not going to say that's called commutative property. You know, whatever you want to do, you can say we can switch those numbers, whatever you want to do, that's fine at this point. Okay? Any questions about that? So that'd be one where, again, that would be really good to use a common, I can switch numbers and get the same answer. Although really, even in that case, so you have to be really, really careful, because even in terms that the students understand, like I can switch numbers when I'm adding them, get the same answer. If that's what you're trying to get them to tell you, you've given them the answer already. Does that make sense? If I want them to tell me, you can switch those numbers and get the same answer when you add. Well, if they read it to begin with, I've given them the answer. The thing I want, and so they may not even get it themselves, but they might say, well, it's supposed to be, and they'll look up there, this is what it's supposed to be. That won't get everybody up. You see what I'm saying? It takes away the discovery. So you have to be careful with the I can statements. So I don't know how I'll do one with this, but again, I would like explore switching numbers when I'm adding them. And that would be the thing I would say, okay, now they're going to tell me, So I don't know how I'd write that. If the teacher says I would have to write that, I would write it, we'd say it once, and I wouldn't even refer to it again, because I say I hope you forget that until the very end. Okay, then we'll go back, do our closure and say, yeah, what did we learn today? Oh yeah, that's what we learned. Okay, make sense? All right, so we have that. Okay, so you kind of see, again, we're using the horizontal, we got the commutative property, I just use the class situation right now, okay? They figured manipulatives, they figured it out, okay? Sense making, they made sense of it, they told me what it is, students understand it, okay? So far so good. Okay, then two more than facts. These are the ones we're going to start with. And what you're going to do is you're going to set the pattern for the students to find the rule. If you tell the students, again, in a traditional way, like I could see, before I learned all these things, I could see me driving to work, and if I was driving with somebody and say, oh yeah, they're going to learn how to add 1 and 2 today. Oh, that must be a real easy day, what an easy job you have. Say, oh yeah, I'm just going to tell them to get the next number. Yeah, that's really quick. What are you going to do the rest of the day? Oh, I don't know what I'm going to do. I'll get on my smartphone, whatever it is. So it sounds like, but really it's not, that isn't what you want to do. Because if you tell them again, just like I was saying before about the commutative property, now math doesn't make sense. Some of them will see it, but some won't. So if you add with 1, you get the next number. If you tell them that rule, then they're going to say, oh, okay, I suppose. So if I have 3 plus 1, you're saying I get the next number. They might even say put 2 down. Well, 2's after 1. See, they aren't making sense of it. So again, you want the students to come up with it. Okay? So what you want to do is this is in first grade. This isn't that hard to do. A lot of these students have already developed this by first grade. Okay? But you're going to have them, ask them, okay, if I add 3 plus 1, what do I get? I don't even need manipulatives. This is first grade. They can do this in their head. If they want to use manipulatives, that's fine. They want to use their fingers, that's fine to get the answer. But I'm just going to put, just like these problems up here on the board, I'm going to collect several plus 1 problems. And I'd say, what are we always doing here on the left side of the equation? On this part over here, what do you see that's common? In other words, what's the pattern? There's always a 1 there. Yeah, we're always adding with 1. Okay? What do you notice about the number we're adding to 1? This one here, and the answer. This one here, and the answer. Oh, it's always 1 bigger. It's the next number. Okay? See how they're developing. You think that's always going to be that way? It's not going to be that hard for most of the students. So let me test it. So you're telling me 8 plus 1 is the next number up, 9. And I say, yeah, there you go, plus 1s. Okay, plus 2 is the same thing. 2 isn't that far away, and the students can think about that. 3 gets to be too much. So 2 more, it's the same type of thing. You're looking at not the next number, but the next number after that. So you're putting a pattern on the board and let the students see that. So that's how you're introducing the plus 1s and the plus 2s. The students are giving you the rules. Okay?
When you do the 3s, is that when you take the number line out?
No. I don't use the number line in this. The number line is in the Ohio Learning Standards, so they do have to use it. But when I'm teaching the basic facts, I'm not using the number. But you could use it in certain places, but I just don't use it here because of the confusion. Okay? So now you're talking to your significant other. You're saying, tomorrow I got to do the 0 facts. What do you mean the 0 facts? Adding with 0. Oh my gosh, you have the easiest job in the world. I mean, how easy is that? Adding with 0. Okay? Well, just so you know, anytime 0 comes into play, anywhere in the curriculum, you have some issues. Students will have issues. Okay? And it's going to start right with here. So if you say something like, so you give a situation, you say, I've got, if you do it in a traditional way, if you have 5 items, and you look in the box to get more items and there's none in there, so you're left with 5. So how much do you have? 5. How do I write that? 5. boy, 5 plus 0 equals 5. But they're going to say, well, nothing changed. What? And in a way, they're right. Why would you write all that stuff just to get 5? They're actually making more sense than we are, okay? So what we want to do is we want to set a pattern. So maybe I'll use like this box with the turtles again. And I'd start off with 5, and I'd look in the box, and there's 3. How many do I have now? 8. Okay, how do I write that? 5 plus 3 is 8. Okay, so I'm starting again. This time I have 5 turtles. I look in the box, there's 1 more. How many do I have now? 6. How do I write that? Okay. Now I'm playing with these 5 turtles. I look in the box, there's none in there. How many do I have now? 5. How do I write that? And see, here's where they're probably going to say 5. I say, okay, but now I've got a pattern set up on the board. I can say, well, how did we do these over here? We always did a plus something. What was the plus here? And they're going to have a hard time with this because they're thinking it's getting bigger. They're saying, well, there was nothing there. Okay, how do I say nothing? What number means nothing? 0. Okay, so now, how am I going to write this? I had 5, and I tried to get some more. I didn't have any more. See, getting them to write, right now, I'm just trying to get them to write that. Nothing with the 0 facts. This is just getting them to write 5 plus 0. And that's going to be a big accomplishment. Because they're going to say, and rightfully, you think about it, why am I writing all that? This doesn't make any sense. Okay, so I might do another set of problems like that to get them to write plus 0. But that's how I get them at least to make some sense why we're putting plus 0. If I start here, like I was saying before, they're going to say 5 plus 0, but you aren't adding anything. But now I've got a pattern. I always start with 5, I get some more. I start with 5, I get some more here. I'm not getting any more, but I'm trying to get more. There's some link there. It's not the greatest, but just get used to that. But when it comes to zeros, those links are always a bit weak. Okay? So you have to really work to try and make those links. Okay? So now this might be a late kindergarten or early first grade type of thing where I'm just getting them to write plus 0. That's my big goal, to get them to write plus 0.
Now, how many days does it take to teach a lesson like that, a 0? Is it like a 1-day lesson?
That could be a 1-day lesson, especially in kindergarten. Yeah. That one, anytime you see those zeros, you might think, because it sounds like, oh, I can do plus 0, plus 1, plus 2 with these. And you might just have some very confused students with that plus 0. That's a tough one. All right, so that's the one pattern. So when we're talking about the 0 facts, we're talking about 2 different patterns. One is this pattern here to get them to write plus 0. That's what we just did now. They don't have the basic facts for 0 yet. They just know how to write plus 0. Okay, the second one is me collecting, just like with the plus 1s and the plus 2s, I'm going to collect a bunch of plus 0 problems. And probably before I'm done putting them all on the board, they're going to say, you know, this is easy, it's always the same number. If you, there's the rule. There's the rule. They're telling you. Oh, so every time I have a 0, you have the same thing? Yeah, why do you say that? And they're going to give you this explanation. They can't explain very well, but they're going to have it. Okay? Well, let's try it out. So you're saying if I have 9 plus 0, I should get 9. Can you show me what that would be? Can you tell me what that would be? And then they're going to tell you. It's like, so they came up with the rule. So here's this very confusing thing that traditional students don't always get. Now they're telling you the rule.
It's going to get even worse in 3rd grade when 0 is 0.
Yeah. Remember the background they're coming from too when you're beginning this plus 0 is that when you add, you're getting something bigger. That's their mindset. Anytime you add, you get something bigger. So now again, remember how I started off early by saying this means, you know, bring them together, and we have a very narrow definition, and we're broadening it with different types of problems, and now they're broadening their understanding of what addition means. Oh, you can actually stay the same when you add. That's a new thing. then when they get to the negative numbers in 7th grade or 6th grade, you can actually get smaller numbers, 5 plus -1. Now you're going down the other way. Okay, and that's when we expand it there. All right, but we're okay with this here. And if they say, like for example, prior to the +0, when you're first introducing addition, if they say, anytime you add, you get a bigger number, you want to say, yeah, that's right. Okay, you don't want to say, no, 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 later on you're going to find out that, just don't go there. It's a development. Okay, you're happy, they got it, that's really good. Okay, then when you get to +0, so do you always get a bigger number? No, sometimes it stays, okay, that's fine. You don't have to say, now you're going to have negative numbers in 5 or 6 years. You don't have to say, oh, that's good, that's really good. Okay? Yeah, they'll figure it out, they'll come across it.
Yeah.
Okay, so now we've got the 0s, the 1s, and the 2s facts already done. I'm going to just do one more set of facts. Just the doubles. Oh, I forgot my 2 of everything book. I'll show you that next time. Okay, the doubles are actually, doubles would be 4 plus 4, 6 plus 6, 7 plus 7. Okay? For some reason, I don't know why, they seem to go, students seem to do very well with them. There's something interesting about them that makes them learn those. I don't know why. I've never heard an explanation why. They just happen to. So what you can do is you can create like flashcards and let them make their own doubles. Like 5 plus 5 might be 2 hands. So they draw 2 hands, it says 5 plus 5, and they have the 2 hands there, and they're thinking, okay, that's 10. I associate 5 plus 5 with 10. Whatever makes sense to them. So you're going to make these flashcards, and you're going to share them, like Lauren, you're going to say, well, I think 5 plus 5 is whatever it is. In the snails book, there's 5 of these and 5. So I wrote snails down. Oh, okay, you want to share that with the class? You share it with the class, and maybe Rachel says, oh, that's a good one. But and then then Kayla says, that doesn't make what? That doesn't make any sense. I like this one. Okay, so you want to make it personal. Okay. So those are the doubles. Now for the higher ones, you see up there it says 8, 8, 16 weight. 9, 9, 18 flower. So if I'm in 1st grade, what I can do is I can use phrases like 8, 8, 16 weight and 9, 9, 18 flower in my regular routine. And by that I mean if you look like on the back board there by the light switch, 8, 8, 16 weight. So let's just say we're going to line up. Every time we line up, I say, okay, 8, 8, 16 weight. And they know, okay, I can go up there and I got to wait by the door. Okay, so now they've heard it every day, 8, 8, 16 weight. So now when I say 8 plus 8 is 16, what does that sound like? Yeah, it sounds like weight. So 8 plus 8 is 16, we already know that. We've been saying it every day. Okay, 9, 9, 18 flower, right by Kayla, there's a flower there, and maybe part of my morning routine is I put a question in there, in the mouth, right there. So I just have that, and it's just part of it. So let's go to the 9, 9, 18 flower. So we do our calendar, and we say, okay, what's the question from the 9, 9, 18 flower? So they keep hearing this over and over, and now they've got 9 plus 9 is 18. So you can think about those really tough problems, and you can, use them as phrases in your classroom, and then suddenly it's part of they got it. Okay? So that's pretty much the doubles. I'll show you the book on Monday. Oh, by the way, next week we have a test scheduled, but it's not going to be next week. It's going to be the week after, right? Because we just have. I think it was we moved it to next week. It's just not next week. Don't tell Kate.
I was like, I should get you this one.
Grace, did you see this one? Oh, yeah. I think they usually kind of feedback for
I'll give it to everybody else next time.
Oh, yeah.
So I
Like,
can-
or they ball like this and then they want to drive. Yeah. I have those too. I have them in the underwear. It's the fact of like them not getting water or taking them from me. I'm not gonna shit. When you have kids, you know, when you're doing shit by yourself. That's just like when you're that. They don't do this to their dad. They'll come in and like, mommy, ugh. And I was like, because I'm taking a shit because that's what you do in the bathroom. Why are you in here? It's not even your time. It's not even your time. Lock the door. Oh, lately I just been popping the bathroom open on them on purpose. Like, oh, you got stink in here. Oh, how you like it? They do this all the time.
Parenting.
Yeah.
Parenting by Tony.
So funny.